up and try again.
Hello everybody. Today we're going to talk about how to process lists, in particular through functions. We're going to create 4 different programs to demonstrate kind of the different capabilities that we can do with functions and lists in Python. Okay, so the task is quite simple. It's just asking you to write a function called process this list, which I call here in my main. So the idea of this program is to return, or actually, of course, take the list as an argument of any kind of list of numbers, and shall return the 3 elements as a tuple. Which 3 elements? Well, the first one should be the smallest value from the list. The second one should be the largest value from the list. And the third one should be the list ordered in ascending order, the one that passed in as a parameter. First of all, let's identify a couple of items that can be critical when we generate this program. The first thing is that we recognize that this function might take argument, and it's specified here is the list. So we're going to create a list and it will be called as an argument. The second thing that you need to identify is that this is a return type function. Remember that we have functions that are void or is non-returning any value functions, or we have the return type. In this case, we will be returning something. What exactly? A tuple. Remember that we have list in Python. In list, you can do a couple things there. You can add, you can remove, you can append, you can retrieve, you can mutate, you can change them, the list. A tuple is a sublist. It also contains values as a list, but you cannot modify them. Basically, you can just, it can, in this case, will be a resulting list that you cannot change it. Basically, you can just have them as a result set. The word result set I will elaborate later on, but a tuple basically is a result set which basically has values already that you're going to use them. It's denoted by the parentheses, whereas the list, they have the square brackets as you can see here on line 8. So the rest things that we need to notice are the expectations from these functions, basically the smallest, largest, and order. As I mentioned previously, I'm going to do it 4 different ways. I'm going to start with the longest way to do this, and eventually I'm going to show you the tricks that you can do in Python. I decided to create a main. I know you don't really need a main in Python, but it's always a good idea to divide and conquer, to have this separation of duties when you create your functions. Right now, we're not doing too much of scripting in the sense that we're going to run multiple scripts, but here it's always important to have a function that triggers the entire program. So that's why we trigger on line 19 our function main. And main on line 8 we create just a random list of numbers. Notice that they're in order. And what I'm doing right here, just to demonstrate before, we're gonna print the original list that we just got it right now. I just decided to put original so you can identify later on for the changes. Now, this is what I want you to pay extra attention. When you define the function process list will take an argument, which will be my list. And when you come back after calling this function, you're expecting a tuple. This is called a tuple. The tuple is this open close parenthesis, and inside of inside of the parentheses you have 3 elements. So this is a tuple that contains 3 values. We got S, L, and my list. So what exactly are those 3 values? S represents the smallest, L represents the largest, and my list is the list that is going to be in order, or in ascending order if you may, after we call this function. So the next step we're going to do, we're going to have to define our function, and we're going to do it right now. We're going to define the function as process this list. Notice that it's outside of the scoping of the function main, before we trigger the function main. So the very first thing, this is the very first version, what we're gonna do, we're gonna declare the variable small, yeah, and it has to be initialized to something. The value larger, it was going to be initialized to something. And since this function requires to return elements, please make the habit to have the word or the keyword return. Yeah, the keyword return basically will indicate that this function, process this list, will report something back when it gets called. And we already know from the previous instruction this is going to be a tuple. So we're going to return the smallest, the largest, and my list. My list, it will be in order. Of course, we need to know what's the smallest, what's the largest. Now, since we're doing the very first, the longest way to do it, we are going to show you how to identify the smallest. The smallest, I have seen implementations that in order to find the smallest of something, you give a very large value and then update it for a very smallest. In similar situation, when you want to find the largest, you initialize this to a very small value and then you update it based on the largest. That works, yeah, that's kind of cool, but I don't really like it too much because you might have very large numbers or very small values, and that's not even true. That's also kind of weird to have a value that is considered to be negative 9999999 or positive 99999. It's kind of sometimes confusing. I have seen this implementation many times, and I don't really pay attention, or I'm not very picky on this part, but to be honest, there's better ways to do it. I have seen other implementations that you can initialize to an actual value from my list, or in an array if you're working with our programming language. So I have seen, for example, you can say, you know what, give me the very first value of my list, and that will be initialized at the small and the largest. In other words, when you process my list, 42 at the very beginning is your smallest and 42 is your largest. And then later on, you're going to start exploring and identifying other numbers, and that's where you make the decision that you should keep that value or not. That I'm going to show it to you. This is the very typical way, or the very typical example when you start looking, for example, when you start studying loops, because you need for every value x that is located in my list, you're going to do something. Here what we're going to do, we're going to check if x happens to be smaller than my current value contained, current variable contained is the smallest. That only means one thing, that you found the new smallest. Sorry. Now, you can also have elif. In case the value that you're currently processed from the list happens to be larger than my current L, which is the largest, that only means one thing, that you found the new largest. So let me just repeat again. This if statement is responsible to find a new smaller value. And this elif is responsible to find a new larger value. So the question is here, why am I using if and else? As I mentioned, this is the very first version. It's a little bit long, yeah, but there is some logic behind that, and I wanted to elaborate a little bit more. I received a couple emails or messages from students that they asking me why, if this is correct or incorrect. This is correct. This is absolutely correct. As a matter of fact, if you have this idea and you translated this idea to probably, for example, Java or C++, it remains the same idea. The syntax is not the same though, but it's the same idea. So this is the algorithm that you should follow. So once you follow this, I'm gonna save this into my desktop, and I'm gonna run the very first version of process list 1. As you can see here, this is the name of our file, and I'm gonna call it right now. Let's see what happened. Boom. All right, the original. So I'm printing on line 9. We print the original, which is right here. On line after calling line 10, we obtain the tuple that we printed here, line the smallest, which is indeed -4. then the largest, which is indeed 224, and then we print the sorted list. The only problem here is that my list is printing my list that is being defined in the main. Yeah, it's not being originally ordered. So this is one of the steps that is missing. Now we can do, before we reporting back on line 24 at this point, yeah, we can do a couple things. We can order them with one of those famous algorithms, for example, bubble sort, insertion, selection, quicksort, merge. I don't know. There's a big encyclopedia that you can find about the best algorithm to order this element. Or you can use the power of Python, and it's considered to be a little bit cheating, but not quite, because at this point we're using Python. We're gonna try to save some time. If you're interested to see how bubble sort and other algorithms to sort works, I'm gonna invite you to see other videos. I can elaborate that in more details. So I'm gonna show you that my list has some embedded function and built-in function. I'm not so sure if you can see this. I'm using Code. It's a Visual Studio IDE that helps you to provide some kind of the functions that it provides, or methods. Sort is one of them. So when you use sort, it's called a stable sorting. Okay, so it gives you the description that it's a stable sort. I'll talk about that in the other data structures videos, what's considered to be stable or not. So before we return my list, we're gonna order them in ascending order, and we're gonna report back. You're gonna report back where? On line 10. Remember that all these lines of code are being done inside of process this list. And process this list will give you back a tuple. And here's the tuple. We have the smallest, we have the largest, and we have my list. And then you report all that in the main. Let's give it a shot now. I'm gonna clear my screen. I'm gonna run this right now. And you can see that now it's a different story. Now the sorted list is in increasing order, and we're working on that at this point. So this is a good demonstration about a couple things. Although this is not my favorite solution, it helps us to demonstrate algorithm analysis, or basically how to extract the smallest, the largest value in the order value. And also help us to demonstrate function call or function definition and function call, and also demonstrates the uses of tuples at this point. Let's work with the next process list example. The next example that we're actually working, it's the same task. The only difference is that now we're gonna manipulate the list. So I'm gonna open here process list2.python, which I already saved it in my desktop. You can see it in my right hand side, but I haven't implemented. I'm gonna implement it in a second. So what do I mean with list manipulation? Yeah, instead of doing that whole for loop to go and extract each value or identify the smallest or the largest inside of the list by using an if statement or elif and the for loop, we can take advantage of the power of lists. So lists, they have this ability to, as you probably already know, my list has this ability to, for example, to have functions like the one that I mentioned. We can have sort, yeah, and that will order them in ascending order. And at this point, we probably already know where is the smallest value. So the smallest value will be, since it's already in order, my list, I'm gonna do my list at position 0. That will contain the smallest value. If you notice, I'm gonna point here to the bottom of this part. When you have a list that is already in order, you must agree with me that whatever element at position 0 will contain the smallest value. So we're gonna take advantage of that ordering in order to extract that information. The next question is, where is the largest value? So at this point, we already know that it's 1, 2, 3, 4, 5, 6. There's 7 values here. So I know where I know what you're thinking. Let's go here at position 6. Why 6? Because we start position 0, 0, 1, 2, 3, 4, 5, 6. and you will find the largest value. In this case is 224. But that is not always true. Especially here is kind of cute because we're working with 7 values. But what happens when you work with 7,000 or 777 or I don't know, 7 gigabytes of information? We don't know what that value is. So there's different ways to identify this part. So the very first thing is to take advantage of the function length. Remember that length gives you the size. Yeah, it returns the number of items in a container. So if you ask, give me the length of my list, this will give us 7. A little bit dangerous because length will give you 7 values. But if you're trying to access position 7, that is not cool because position 7 will give us a array index or out of bounds exception. So what you can do is you just have to subtract 1 and that will give you the index 0. I'm sorry, the index length minus 1. At this point, we can just simply return. We're going to put the tuple containing S, L, and my list. Notice that I didn't move anything from the main. The main remains the same. So what I'm going to do here, I'm going to go to my console. I'm going to run the second example, which is this. And I got the same result. Nothing changed. Everything is the same. Yeah, with a different strategy that we use. Here we're using indexing in order to extract the information, and we kind of manipulate it by using the functionality of my list. Notice that we don't have an if statement, we don't have a for loop, so this gives you flexibility in case you like to do some indexing. Remember, my list or any kind of list that we have in Python allows you to slice, okay? And we'll talk about, there's another video that talks about sliding the entire list, slicing, sorry. You can perform slicing on the list and you can extract ranges or you can extract some certain values. That's the example number 2. Example number 3, we're going to demonstrate similar what example number 2 is, but we're going to take advantage of there's a slicing part that it's a little bit too much. Yeah, remember that Python is recognized by the situation that you can, the least amount of code you provide, the more Python you become, the more popular, the more flexible it is. So we're gonna do something similar. We're gonna sort this value, the whole list, and we're gonna create smaller value, which is my list at position 0. I like that. So this is a slight modification for our previous example. And the largest value is basically my list. And I'm gonna exercise this cool thing that Python has, which is a wrapper. Basically, you can go from 0, 1, 2, 3, 4, 5, 6, 7, but also 6, sorry. But also you have the ability to go in negative values. And the -1 basically wraps up. So -1, it will be the last value in the list, my list, which it happens to be the largest value. So it's kind of cool that, yeah. And we're gonna return the tuple containing the smallest, the largest in my list. Let's see, I'm gonna save this thing. I'm gonna call Python 3, and this is gonna be the third value, the third example. And there you go, it's the same result. Yeah, I didn't modify anything that we have here. I just wanna demonstrate this flipping part. And the last part, what we're interested to do, we're going to use the complete built-in functions that we have in Python in order to make this this assignment, this problem, very simple, in using just a few of functions calls. So first thing, we order the list in ascending order, and then I want you to pay attention on the following thing. It's we're gonna return yeah, the tuple of the smallest. But the smallest, we haven't created any variable. Of course not. We're going to use the built-in function, and look what this is suggesting. The built-in function allows you to take a collection or iterable object, yeah, as an argument, and it will identify the smallest value. So here we're going to put my list as the smallest, and then if there's a mean, gotta be a max, my list. And of course, we already have in order my list, so we're gonna do it just simply like that. Very, very fancy, very nice. We only have 2 lines of code, and we're gonna run this program now, the Ford, and we will see the same result. Notice that we obtained the same result, different strategy. So this is kind of cool to see this kind of different processes to obtain the same result. If you have any questions, let me know, and I can elaborate a little bit more in the comments. And I will post this on the website as well. Thank you very much.